This is the first part of the Chump project. This is the code part of the project. So this is the code that I have written, and I will be going through and explaining what it does. So this code is supposed to act like a vending machine, where as you keep inserting money, you have to insert less money, and once you reach the amount inserted, it will dispense a soda, and then it will subtract one soda can from the reserve soda cans it has. So to write this out in high level, we have to set how many sodas we have. So S equals 10, so there are 10 sodas, and the amount of money it will cost is 15 cents, or it could be $15, but we're sticking with cents for this. And then to write this out, while C does not equal 0, C equals C minus 5, or C equals minus 5. So every time you are inserting 5 cents into the machine, and once the amount of money it costs for a soda reaches 0, it'll dispense a soda. So while S is not equal to 0, S subtract, so S minus minus, and this will mean that every time you get a pop, it'll take away one pop from the reserve. And then once S equals 0, it will move on to pause, and that will end the program. So to write this out in Chumpanese program or assembly language, we have our different addresses. So this is the line it is on, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 13 lines of code in here, and then we have a bunch of different instructions over here. So load, store to, if 0, subtract, go to, and read. So what the load command does is it will load 10 into the accumulator and increase the program counter by 1. So the program counter it'll count up as the program goes, so that's the address basically. So program counter equals 0, then it's 1, 2, 3, and so on. So the next command, store to, it says the memory at location S is equal to the accumulator. So memory S, which is 0 in this case, equals the accumulator, which is 10. And then program counter plus plus. So that goes the same. It's load 15 this time, and store to C, which is memory address 1. And then we have the next command, if 0. So this is asking if the accumulator equals 0, then go to the program counter line 7. So 7 right here, 7 here. And so that will move it to program counter line 7, which is read S. So if it's not 0, it will just continue on in the program. So the next one is subtract 5, and this will make the accumulator minus equal 5. So it subtracts 5 and then makes the accumulator equal that value minus 5. So then the next command, the go-to command, it'll basically set the program counter to 3 in this case, but it will set the program counter to whichever address you want it to be. And then the final command I've used in here is read S. So this will make the address equal to 0, which is our S address, and that's what it is. So to go in a bit further depth, we have our program line here, 0, 1, 0, 0, 0, 1, 0, 1. So this is the subtract 5 command. So there are a couple parts to this line of code. There are 3 different areas. There's those 3 bits right there, this one right there, and then the 4 leftovers. So the first 3 ones, the ones in green, are the actual program. So in total we can have 16 programs. Right now we have 14, and we can create 2 more. But so this is basically the program. You have 1 through 8 pretty much, and then you can have a 0 or a 1 here. If it's a 0, it'll mean that this part matters, the red, and if it's a 1, it'll read it from memory. So this will not matter, and you don't have to include it. So the red is the constant. So in this case, it is 5. So 8 is 0, 4 is 1, 2 is 0, and 1 is 1. So that is 4 plus 1, which equals 5. So the next part of the chump build is the Ben Eater clock. It basically has an astable pulse, which can be changed in speed to be slower or faster. A monostable pulse, which is a button that has a fixed value of how long it stays on based off of this capacitor, and a bistable, which will change from one to the other on this LED. And then this is all combined through these three different logic gates to create our output. So right now it is in monostable mode, so this output is only on when we press the button. So if you look here and here, they are the same and they'll be on for the same time. And then if I were to switch it, this now reads off of what the astable pulse is. So moving on, this is our program counter, and it will be reading, it'll take in a clock pulse and it'll output what the address is that we discussed earlier in the code. So there's a couple of things here. This is the SN74LS161, and there's 3 different buttons here and 4 LEDs. So this first button is a clear button. It will reset all these LEDs to off. And then this button is a load button. So there's a load pin. It's the final pin right here. And that basically sets the inputs, which are these. So this is 1, 0, 0, 1, or high, low, low, high. So when I press these 2 buttons, this LED and this LED should turn on with a clock input. So if I held down these 2 buttons and use our monostable clock, you will see that'll be on, off, off, on. So that's the load pin. It sends the signal directly through. That's how we can use goto commands to change which address we are on. If I switch this to astable mode and I clear it, which turns it all off, you can see it'll count up, and this does count up on the rising edge of the LED. So once this LED turns on, it'll count up by a pulse of 1.